Hello and welcome. In this video, we're going to look at the specifics of the amplitude envelope. And the amplitude envelope is one of the most important things you're going to adjust in a synthesizer. Often you'll have a patch that's almost right, and you want to make it perfect. Very often, it's adjusting the amplitude envelope that's what's going to make it perfect. The amplitude envelope describes how the sound evolves over time, or more specifically, how the amplitude of the sound evolves over time. And an envelope is our first modulator. And a modulator is something that controls something else. In this example, we have the envelope, which is just 4 parameters: attack time, decay time, sustain level, and release time. And that envelope is controlling amplitude. It's like a path that happens every time you hit a key. If I want a percussive type of sound, it might have no attack, so it goes right to the top as fast as possible, and then a long decay, so it slowly releases. That might be like a cymbal. And we can use this amplitude envelope in a variety of settings to kind of create the dynamic shape of any sort of instrument. Now, we're referring to the amplitude envelope here, and that is the most common one, and it's one you'll find in nearly every synthesizer, kind of hardwired in. There'll be an A knob, and that's going to be the attack time of the amplitude envelope. But an envelope is a general purpose device, and there can be a filter envelope that controls the cutoff frequency of the filter, a pinch envelope that controls the pitch. But the most important one is amp envelope, and that's what we're going to check out right now. Let's see how it works.
This is a display of what is going on with the envelope. The top bar shows a yellow line, and that's going to be on every time I play a note on my keyboard. The green area underneath shows what the envelope is actually doing to this level right here. So though you won't see this fader go up and down, it actually is bringing that up and down in time. And that's what modulation does. The trick about modulation is it's interacting with other parameters in the synthesizer, but you're not always seeing them move, right? So you just kind of have to hear it and know what's going on. So we have set up here is a basic filtered sawtooth waveform, and I have the amplitude envelope set up like an organ. And if you press an organ key down, the sound starts, and if you let go of the organ key, the sound stops. So it functions like a switch, in that it's on as fast as possible, off as fast as possible, and it's at full volume when it's on. And let's just see what that looks like in this envelope display. I'm going to hold a note, and I let go of it. And we see that the note on and note off, and the green area is the same exact length. One more time, and note off. So this is a 4-stage envelope, but I'm going to start with a 3rd stage, which is my sustain level. Now, what happens if I bring the sustain level down to half, 0.5? Now, it's quieter, right? We see that the yellow area is when the note was pressed, but the note is quieter. If I was to change the sustain level while the note was holding, I'm actually changing the level at which the note sustains, right? So the weird thing about learning about amplitude envelopes is that these words like sustain and decay take on a slightly different meaning than you're used to. We typically would say that a guitar has a lot of sustain, or the low note on a piano has a lot of sustain. And that's talking about the amount of time it lasts, and that's kind of a general usage of the word. When we're looking at synthesizers, though, sustain is an amplitude, it's a level. And while I'm holding the note, changing sustain is like changing the volume on the main output. Check it out, if I bring it all the way down, the volume's going to go away. 0. We're up to 100%. All right, so sustain is a level. Now, often, we want sounds to kind of fade away once we let go of the note. And that's changed by release time. If I increase my release time, I'll play a note and I'll let go. And let's see what happens to the display here. So we can see that the note off happened at the end of that yellow line, and the green lasted a little longer. Let's try to increase release even further. Hold the note, then I'll let go. And we see that the yellow is when the note ended, and it fades out based on that time. The longer the release time, the more time it takes to go from full volume, or excuse me, from the sustain level volume down to 0. That's your release time. Attack time functions similarly, but at the beginning of the note. So if I increase my attack time and hold the note down, it will swell in over the attack time. So you're defining how long it takes. Now that's also a weird one. Usually you would say I want a lot of attack on a note, meaning you want it to be stronger in the beginning. But if I increase the attack parameter, it fades in. So again, these terms take on different meanings when working with synthesis, but they're very descriptive. And that's why I like to keep saying to myself attack time, decay time, sustain level, and release time. In normal language, you'll just say attack, decay, sustain, and release. But if you're always thinking about that second word, is it an amount of time or is it a level, you'll have much more success with envelopes in general.